So many legal professionals spend about 20 to 40% of their time trying to understand their legal document, trying to review and understand the whole meaning of the legal document. So because of this, I've tried to train a model that is able to summarize their legal documents, capturing the most important part of the document. So to do this, I use this data set from Kaggle, and Gemma 2B was used was fine-tuned using LoRa. So I'm just gonna showcase you like the data set and how it looks like. So for the data set, and this is why I loaded the data set, and as you can see that we have like 7,000 entries for train. The data was already split into train and test. So this is the number of rows for train, and the number of entries for test is 200. So this is just like an example of how the dataset looks like. So you are given about 2 to 5 pages of a legal document, and this is more like a summary. So for this part, yeah, I was trying to visualize the number of tokens to understand the meaning, like to understand the whole data set. Then so the data set was already split, but I had to also split again and specify the number of training examples that I needed, and that can also train faster given the GPUs that I have. So for train, I chose about 4,000 entries, validation 500, then 300 for test samples. So for this, I also had to pre-process this dataset first. But first, I had to give like an instruction, like a prompt, like an instruction template, which is like a prompt, the input and the output, so that the model can understand what it has to do. So as you can see here, right, so this one is more like the prompt. So summarize the following legal document. Then this is more like the whole document, and then you get your response. So this is more like was just specifying the number of tokens at maximum number of tokens, of course. Then there was also some pre-processing part that we also done, like to remove some special characters to make sure that the model also understand like the whole sentence, like to make sure that understand from start to finish. And also padding was also done to make sure that the model is like equal length of equal input length. So yeah, after formatting the data set, I'm sure you can see here, right? Every sentence is on its line right now, as you can see. Then these were like just some functions for tokenizing the data sets, and the data set was tokenized. Then here we're just like selecting the model that we are using and specifying like some like parameters that we have to be using. So to make sure that my GPUs, since I was training on CAP, I like reduced like to 4-bit quantizations. You can also improve to 8-bit, 16-bit, but to accommodate for my GPUs to reduce the training cost, I used like 4 bits. Then okay, so this was like where I loaded like as you can see, like there's where you can apply LoRa, the parameter efficient fine-tuning. So you will load the base model, then apply the parameter efficient fine-tuning, which was defined on top here. So this was the, the, the base model. So what LoRa does is it just freezes some of it freezes all the weights of the base model. Then you now retrain a smaller part of the weight. So it compresses into a smaller matrix, then just train that part. So this also reduces like they say that the base model is about 200 billion parameters. But let me just show you after applying LoRa the parameters that we actually have. So let's just go down. So this was just like specifying the number of ranks for the LoRa. Actually, you don't train the bias. We just left the bias as it is. Then also dropout was also applied. So yeah, after applying LoRa, which is like parameter fine tuning. So you can see that right now, you can see that the trainable uh, parameters are now about 1 million, 1,028,000 something. Then the total parameters that you can see, like we have about 1 billion, which means we are only training 0.12% of the parameters. And this really helps for fine tuning and make sure that your model specializes in the part that you're supposed to be doing. So all this was trying to just specify the number of epochs, the warm-up ratio, this one, the learning rate, the number of epochs. I only trained 2 epochs. Then the batch size and accumulation. So this was like specifying the number of devices, the GPUs. So these are all defined. And after that, now you initialize the trainer. So you specify the model, you call your data set for training, the evaluation data set, which is, they are all tokenized, we are supplying the data that is tokenized. And yeah, this is how it worked. And this was the training part, and it trained about 500 steps for 2 epochs. And this took about um, 10 hours training. So my final loss after training was 1.18. And after that, I had to save my module. But for the evaluation part, there's something that I need to show you, like evaluation. So I evaluated my model with different evaluation techniques like ROG, BET, and Perplexity. So let's jump into the evaluation part. So as you can see, right, the ROG was 0.9%, 0.29. So this was fair enough for my model, and it was means it was capturing the semantic of the whole sentence, to understand the semantic of the whole sentence. And you can see also this bet score, it was also higher. The bet score, it was also higher, which means that the model was able to understand the whole sentence and the semantic recall. So this is more like trying to showcase you the generated summary after trying to test your model. So yeah, this is the part for the summary. It's not way different from the reference summary. So right now, I just want to showcase you like how the fine-tuned model improved from the base model. So remember, we had our base model, which was the Gemma 2B. Then after fine-tuning, we see that our model improved by around 2.98%. And by this, it means now it was able to capture and understand the legal documents. So all this was trying to print some examples of the generated with the zero shot, which means that you don't give it like some examples to understand. So I tried with zero shot to to predict the summary of the document for the legal. So after training, this was just like my model output. So like it captures, so this was the evaluation results for the model. Then the adapter sensor. So this is the part of only the trained parameters that were trained. So these are adapters. So this is like, you want to use this one, you can just use these adapters and the base model, then combine it. Then now you have your fine-tuned model. Then this one is more like the app.py, and my model was deployed on Hacking Phase using Gradio. So first I had to make sure that my model can understand which text is given. Is it a legal document or it's just a general document? So what it does, I gave them, like, there are some keywords that we know that they are found in the legal documents, like court, plaintiff, defendant. But given that these words, this set of words are not identified in that document, you'll get it's not like an error, but it will just tell you like a short response that provides a legal document. This is specifically for summarizing legal documents. So here I'm just saving my like creating like for my creating the interface for Gradio. So without wasting time, I just wanted you to showcase you like the prompt so that the model can understand. So yeah, this is the part. So we tell you this is the instruction that the model reads. So summarize the following legal documents, then you give it the input, then you get the response as the prediction part. So without wasting time, let's jump into the uh to the prediction part. Right. So this is the interface and it's on Hugging Face. So, of course, this is for academic, and you can just be playing around with this one. So, you're given this part. This is where you paste like your input with legal document. It can be about maximum number of tokens about 1,024, 1,586 tokens. So, you can give it like it has like a limit where you can upload. But we can see that from this document, it's able to summarize uh, this whole document. So we can say this application was dismissed by the learning judge for Madras Court High Court in January 1956. So if you check on this one, dated April 1956, so this is just trying to show like it's a summarized. So it's not giving us the decision of the Supreme Court in the case of RC James versus State shows how important it is to consider. So this is more like the summary. So these are more like examples that you can use, but they are not complete examples. They are more short. So the summary can be vague, but these are like short, and it can also summarize. I also displayed some model performance. You can visualize the new. Yep. Thank you.